Okay, so I'm using my notes to like explain this, but I'm gonna send you pictures of my notes after because I think he explained it really well. So yeah, so for partial fractions, there's three main types. In the notes, he refers it to P and Q, but it's the same thing as saying numerator and denominator. So the three main types is when the degree of the numerator is less than the degree of the denominator. The second one is when the degree of the numerator is greater than the degree of the denominator. And then the third one is when there is a irreducible quadratic. Right? So for this one is the easiest one, when the degree of the numerator is less than the degree of the denominator. And for this one, when the degree of the numerator, let's say it's x cubed, is greater than x squared, you have to long divide first. So you have to long divide the whole thing, and then you do the same steps as the first one, and then same steps as first. But that's after you long divide. You have to long divide first. So yeah, so let's just do the first type. So this is the example I have in my thing. X minus 1, x plus 4. Okay, so right now you see how the degree on the numerator is less than the degree of the denominator, because the degree of the denominator is x squared, and then the top doesn't have anything. So for this one, you will have the type like a over the first factored part plus b over the second factored part. And in the notes, he refers it to you know what I mean, as this. A2 over x minus 8 plus dot 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 until you don't have no more factored parts. So this like a1, that's a2 is b, and then this refers to like as the factored, how many factored parts. So let's say you had x minus 1, x plus 2, x minus 3. So then you will have, if it was like this, you will have a over x minus 1 plus b over x plus 2 plus c over x minus 3 and so on, you know? Yeah, whatever. Okay, so we have this right now, right? So now we need to solve, this is going to be the same thing as this because it's integral, so it's the same thing. So now we have to solve for what a and b is. So in order to solve for that, you have to look for the convenient values. Oh no, I lied. First, you have to bring everything up top, right? So then you multiply everything up top. And then, you know, whatever you do to one side, you got to do to the other side. X minus 1, x plus 4, plus b, x minus 1, x plus 4. And a is over x minus 1, and then b is over x plus 4. Okay, so now you do cancellation. These two cancel out. This one cancels out with this one. This one cancels out with this one. So now you're left with 3 equals a times x plus 4 plus b x minus 1. Right? So now you have to solve for a and b. And in order to do that, you have to look for the convenient values. And convenient values is basically oh, that's so wrong. You know what I mean, though. Convenient values is basically you just try to get whatever's in one of these parentheses equal to 0. So like, how would you make this a times 0? Like what would x have to be? And it's basically -4, right? So then you plug in. X equals -4, right? So 3 equals a -4 plus 4 plus b -4 minus 1. So then it's 3 equals a times 0 plus b minus 5. So you see that's why it's called the convenient values, because this could easily cancel out itself, and now you just solve for b. It's like, you know, easy. So then divide by 5, divide by -5. So then b equals -3 over 5. That's your first one, right? And now you could just look for the other convenient value. So what will make this equal to 0 so that you could solve it for a is 1, right? So then at x equals 1, 3 equals a, 1 plus 4 plus b, 1 minus 1. So then 3 equals a 5 plus b times 0. This cancels out. Over 5 over 5. A equals 3 over 5. So that's your other convenient value, right? So now that you found your values, you just plug it back into this. So we had the integral of 3 over x minus 1 times x plus 4 equals a over, oh, sorry, I'm too strong. A equals x minus 1 plus b over x plus 4. And then we already found out what a was. A was 3 over 5, and then b was negative 3 over 5. Right? And now you do now this is easier to solve than the first one, right? I guess. So then in order to solve these, I always put the constant outside the integral. So it will be 3 over 5 integral 1 over x minus 1 plus, and then I put the constant outside. That's what I always do. Negative 3 over 5 integral 1 over x plus 4, right? And then this is in the form of 1 over u du. So it's like basically you have to, in order to do this, you do the ln. So then the integral, the antiderivative of this is ln of x minus 1 times the derivative of what's the inside, and the inside is 1, so you just multiply it by 1 and it's the same thing, plus negative 3 over 5 because the constant is outside the integral, times ln of x plus 4. Same thing. The derivative of x is 1, so you don't have to multiply that by anything. So then it's basically 3 over 5 ln of x minus 1 minus, because I'm just, plus negative, minus 3 over 5 ln of x plus 4. And then you could combine these, like using the log rules. You could factor out the 3 over 5, so it will be ln of x minus 1 minus ln of x plus 4. And then this is the log rule of the subtraction, which is with division. So it's 3 over 5 ln of x minus 1 over x plus 4. And that's your answer. And you could put plus c, I forgot. Yeah, because there wasn't any bounds. If there was a bound, then that would have been a different story, but there's no bounds, so you could just put the plus c. I don't know if your professor is iffy on that, but yeah. That's how you do the first type.